So now that we've introduced the concept of factor methods for Java completable futures, let's talk about how to apply those factor methods by looking at an example. And this particular example, as usual, is in my GitHub repository, and it's in the EX8 project in the Java 8 folder in my live lessons repository. So this will be a variant of what we've looked at before. We're going to use supplyAsync to initiate the multiplication of two big fractions. We looked at something similar earlier when we looked at using those basic Java completable future features. But in that case, we explicitly created a thread and completed the incomplete completable future. And now we're going to use the supplyAsync factor method, which will make the whole thing more integrated and satisfying in a lot of ways. As before, we have some strings that are going to represent the big fraction numerators and denominators. And we start out by calling the supplyAsync factor method, which is a static method on the completable future class. And that is going to arrange to execute what's provided here, this particular supplier lambda, in the common fork join pool. So that's kind of saying, schedule this thing for future computation. And I'll take a look at that in a second and see how it works. This supplier lambda multiplies two big fractions. This looks very similar to what we saw before. The main difference being that there's no complete method on some incomplete completable future. Instead, this is more self-contained. As before, the computation here in the supplier lambda, which is going to be queued up in the common fork join pool by supplyAsync, that will end up running asynchronously relative to what's happening over here in the calling thread. So those two things will run in parallel, as you can see here in the interaction diagram. The join method will once again block until the results are complete. That's really no different from what we had before. And one of the nice things about doing it this way is we don't have to explicitly call any Java threads, and we don't have to explicitly complete the incomplete completable future. So the whole thing is more self-contained. In fact, if you take a careful look at this, you can see how supplyAsync returns a completable future, which will then be accessible for use later in the calling thread for whatever purposes we want to use it for. In this case, we're going to use it to join on. So again, we don't have to explicitly complete the future since supplyAsync returns it directly, thereby making the whole API a bit more fluent and more seamless for use. However, we haven't solved all the problems because we still are obliged to call join here, which will block the calling thread until the computation that's running in the background has completed. And that remains an issue with this approach. So the fact that we know now how to initiate an asynchronous computation is good. It fixes some of the problems we had before with using Java threads and incomplete completable futures. However, we are not out of the woods yet. And so we'll have to take a look when we get to the more advanced completable future features, in particular the completion stage features, to figure out how to avoid blocking. And I'll keep underscoring this over and over again. In fact, this is most likely going to be a good quiz question for next quiz about why blocking is an important issue to try to avoid. Like, what are the issues that it incurs that we would like to get around by using other means, particularly completion stage method. So that's the end of our discussion that illustrates how to apply factor methods in order to compute these big fraction multiplications in a background in a more clean and convenient way than what we had done previously, focusing only on the basic Java completable future features.